So our new topic is laboratory preparation of hydrogen. Okay, so we are going to start laboratory preparation of hydrogen today. So you can see in your book also in figure, this is a structure is here. This is structure is called Watt's bottle. Okay, in which the reaction of diluted H2SO4 and granulated zinc is uh, proceed, by which zinc sulfate is formed. As you know, why we are not taking original zinc or pure zinc here, because it can react here and the gas or hydrogen gas which will be then compress it. Okay, and the hydrogen gas is move upwards because it is lighter than water. Okay, so here in this apparatus you can say hydrogen gas is formed. If you see here, laboratory method for the preparation of hydrogen we are going to discuss today. So in the laboratory, hydrogen can conveniently be prepared by the action of dilute sulfuric acid or dilute hydrochloric acid on granulated zinc. Okay, as I discussed earlier on this class. So zinc is reactive with dilute H2SO4 and it displaces hydrogen, and zinc sulfate is formed and hydrogen gas is liberated here. The details of the method are as follows. If we discuss about in detail, so what are the reactants used? The reactants required for the laboratory preparation of hydrogen are granulated zinc and dilute sulfuric acid or dilute hydrochloric acid. Okay, so whatever acid we are taking is sulfuric or HCl, it should be dilute. Following points are important to note. Okay, first is granulated zinc is commercial variety of zinc. It is in this method pure zinc is not used. This is because pure zinc is non-porous. So you can see here that granulated zinc is a commercial variety of zinc. In this method pure zinc is not used. This is because pure zinc is non-porous and its reaction with the dilute acid is slow. The granulated zinc is impure and has a porous nature due to the presence of impurities in it. These impurities speed up the reaction by forming electrochemical couples. Okay, so you can understand that this granulated zinc is non-porous. That's why because impurities in it, that's why these impurities speed up the reaction. Okay, so second point is that concentrated sulfuric acid cannot be used as it forms sulfur dioxide gas instead of hydrogen gas. Okay, if you see here, concentrated sulfuric acid cannot be used. Okay, as it forms sulfur dioxide gas instead of hydrogen gas. If you used only concentrated H2SO4, it means it's in its original form. Okay, without making diluted when we add you I think already know when we add water in a acid it will be diluted. So if we use only concentrated H2SO4, it will be form sulfur dioxide instead of hydrogen gas. Third point is that nitric acid also cannot be used because it is a strong oxidizing agent and oxidizes the hydrogen formed in the reaction, okay, to water. So nitric acid, why we are not using nitric acid? We are using two strong acids, sulfuric acid and hydrochloric acid only, because this nitric acid, okay, strong oxidizing agent and it oxidized hydrogen when it formed ultimately into the water. That's why we are not using it. So what are the apparatus used here? The apparatus used for the laboratory preparation of hydrogen is shown in figure 6.1. Okay, it consists of a valve bottle. Okay, if you see in figure also is fitted with a thistle funnel in one mouth and a delivery tube in the other. Okay, you can see here thistle funnel is here. Okay, and one is a delivery tube in the other. The one of the holes of a beehive self placed in a trough of water. If you see here, a gas jar filled with water is placed in inverted position over the beehive self. Okay, you can see this is the inverted jar. Procedure. Now we talk about the procedure here. Some pieces of granulated zinc are placed in the valves bottle and the apparatus is made airtight. Okay, first what we do, we just add some pieces of granulated zinc, okay, in the valves bottle, and apparatus is made airtight, okay, by these rubber. Okay, then now dilute sulfuric acid or dilute hydrochloric acid is poured through the thistle funnel. The reaction takes place at room temperature and no heating is required. Okay, at the room temperature this reaction will be occur. We have to not provide any heat from outside. A brisk, if you see here, a brisk effervescence with the evolution of gas is seen inside the bottle. Okay, as you know, hydrogen gas is lighter than water. Okay, so it will be comes upside. Okay, and you will be see a bubble like structure here. Then how you collect this hydrogen gas? The evolved hydrogen gas is collected by the downward displacement of water. Okay, downward displacement means, as I already told you, because it is heavier than uh, hydrogen, that's why it goes downward. Okay, so this was known as downward displacement of water. The gas coming out from the delivery tube displaces water filled in the gas jar downwards and gets collected in the jar over water. Pure dry hydrogen is collected either over mercury or in a flask previously evacuated from air. So, following points are important to note. First is hydrogen is almost insoluble in water and therefore can conveniently be collected by the downward displacement of water. Okay, because it is insoluble in water, it is very convenient to collect it. Second point is, although hydrogen is lighter than air, yet it cannot be collected by the downward displacement of air. Okay, this is because hydrogen forms an explosive mixture with air. Okay, so we are not collected it by the downward movement of air because it is very explosive in nature when it mixes with air. Third point is zinc and dilute H2SO4 react to give hydrogen slowly. The rate of formation of hydrogen can be enhanced by adding little CuSO4. Okay, so you can enhance the rate of formation of hydrogen by adding little CuSO4 in it. Okay, in the solution in which we take only dilute H2SO4. If you are use little bit CuSO4, also the reaction will be take much faster. What are the precautions here in this method? The apparatus should be leak proof. Second, no flame should be present near the apparatus. Third is the outer end of the crystal funnel should dip in the acid present in valve's bottle. Fourth one is hydrogen gas should be collected after the expulsion of all the air from the apparatus. Okay, so these are the precautions which you have to take in every experiment. Next is purification of hydrogen gas. Since granulated zinc is impure, the impurities present in it may react with the dilute acid used in the method to form traces of gaseous impurities. Okay, thus the hydrogen gas obtained by this method is not very pure and may contain the traces of gaseous impurities such as arsine, okay, ASS3, phosphine, PS3, hydrogen sulfide, H2S, etc. Okay, as we know that if you are using impure metal, okay, impure granulated zinc, so the gas you obtained, it also be impure. So we have to pure first we have to do purification of hydrogen gas. So these impurities can be removed by passing the impure hydrogen gas successively through the following reagents. Okay, first is silver nitrate solution. It removes the impurities of arsine and phosphine. Okay, first we successfully do uh, passing of this impure hydrogen gas through silver nitrate solution, and it removes the impurities of arsine and phosphine. Next one is lead nitrate solution. Lead nitrate solution, it removes the impurities of hydrogen sulfide, potassium hydroxide or caustic potash solution. It absorbs the impurities of nitrogen dioxide, carbon dioxide and sulfur dioxide. And last one is anhydrous calcium chloride. It absorbs moisture present in the hydrogen gas. Okay. So these four types of reagents are used to the purification of hydrogen gas, and their functions are different. So one note is here: sulfuric acid is not used to dry hydrogen as it oxidizes hydrogen to water. Okay. Nitric acid, either dilute or concentrate, is not used to prepare hydrogen from metal because nitric acid is powerful oxidant and thereby oxidizes S2 to H2O. Okay, which we read already here. Reaction also given. Concentrated sulfuric acid is not used because this too is oxidizing agent. Okay, so we are not using concentrated sulfuric acid also. Manganese and magnesium are the only metal which react with dilute HNO3, and that it means only 1% of HNO3 to liberate hydrogen. Okay, so we can make a reaction with the nitric acid which is diluted uh, by the metals like manganese and magnesium only. This is the condition. In case of magnesium and manganese, the oxidizing action of HNO3 is much reduced because of its over dilution. Lead is not used for preparation of hydrogen with dilute acids such as dilute HCl and dilute H2SO4. These on reacting with lead forms insoluble coating of PbCl2 and PbSO4, okay, which mean lead chloride and lead sulfate respectively, over lead surface, and thus reaction ceases. Okay, so we are not using lead, okay, in the preparation of hydrogen gas. Next is manufacture of hydrogen. Okay, there are several methods for the used for commercial production of hydrogen. Okay, some of important ones are as follows. When we are want to get a hydrogen for the commercial production. Okay, first is Bosch process. In this process, hydrogen is manufactured in the following steps. First is production of water gas. Steam is passed over red hot coke at about 1000 degrees centigrade in a specially designed converter. When a mixture of carbon monoxide and hydrogen gas are known as water gas is obtained. Okay, so when we just pass a steam over red hot coke, okay, it is the temperature here is 1000 degrees centigrade. Okay, and carbon monoxide, sorry, and hydrogen gas is formed here, so which is known as water gas. Next is reduction of steam to hydrogen. Okay, water gas thus obtained is now used for the reduction of steam to hydrogen. The water gas CO plus H2 which we obtained, now we have to uh, get its reduction of steam to hydrogen. The reduction is carried out by carbon monoxide present in the water gas. Water gas is mixed with steam and the mixture is passed over a catalyst containing a mixture of ferric oxide and chromium oxide at 450 to 500 degrees centigrade when CO is oxidized to CO2. So you can see here, okay, when a steam is passed through uh, this water gas at the temperature of 450 to 500 degrees centigrade, so you can see here this CO is oxidized to CO2 here. Okay, so this CO is carbon monoxide is oxidized to carbon monoxide and we will get the hydrogen gas. The resulting mixture contains about 2 volumes of gas, 1 volume of carbon dioxide and a small amount of unchanged carbon monoxide. Okay, so third one is separation of CO. Okay, carbon dioxide is removed by passing the gaseous mixtures through water at 25 to 30 atmosphere pressure when CO2 dissolves in it and is almost completely removed. So carbon dioxide is removed by passing the gaseous mixtures through water at 25 to 30 atmosphere pressure. Okay. Traces of carbon monoxide is still present and are removed by passing the gas under pressure through ammoniacal, okay, ammoniacal cuprous format in which it is soluble. After the complete removal of carbon dioxide and carbon monoxide, pure hydrogen gas is left behind. So this is the you can say Bosch process or commercial process to get the hydrogen gas. Next process is by electrolysis of water. This process is used at those places where electricity is cheap. Okay, the process gives hydrogen of very high degree of purity. Okay, the method involves the electrolysis of water containing a small amount of an acid or a base. On account of electrolysis, hydrogen gas is obtained at cathode while oxygen at anode. Okay, so you can see if you do uh, lysis of water here, okay, it will break down into its ion, hydrogen and hydroxyl ion. So at cathode, cathode means the cell which containing minus charge, and at anode it contain plus charge. So here is minus charge, and what will be here? Here is it loses one electron. Okay, uh, adding one more electron here, and it reduced to hydrogen. Okay, monohydrogen at as it not you can say live independently here. Okay, monoform of monovalent hydrogen, so it will form the hydrogen gas. At anode you can see 4 hydroxyl ion. Okay, it will be lose the 4, you can see that electrons. Okay, and water is formed here. Third is from natural gas. Okay, now how we will get the hydrogen from natural gas? Natural gas, mainly composed of methane, is obtained from petroleum wells is mixed with steam and then composed of 30 atmosphere. Okay, now it is passed over heated nickel at about 800 degrees centigrade to give water gas. Okay, so you can see in figure So in equation, methane is reacting with steam, okay, and pass through overheated nickel about 800 degrees centigrade, okay, and 30 atmospheric pressure is here. So CO plus 3H2, it means water gas is formed here. The water gas formed is subjected to Bosch process to get hydrogen, okay. It is the earlier process which we will read already. So after that, all the you can say reactions are taking place according to Bosch process. Now we will discuss about some properties of hydrogen. First is physical properties. It is a colorless, odorless, non-poisonous and tasteless gas. It has a very low solubility in water. It is highly inflammable and burns in air with pop sound to produce water. Sometimes the question also asked in exams that which gas is originated or evolved with the pop sound, so it is hydrogen gas. And therefore, it should be handled with care. It is non-supporter of combustion. It is the lightest among all the non-substances and possesses a density of 0.0899 gram centimeter minus 3 cube minus 3 or cube. Its melting and boiling points are minus 259.2 degrees centigrade and minus 252.6 degrees centigrade respectively. It is readily absorbed by certain metals such as palladium, platinum and nickel. This phenomenon is known as occlusion. Okay. Due to very low critical temperature, it is very difficult to liquefy hydrogen gas. Okay. As it has very low temperature, you can see here. Okay. So it is very difficult to liquefy it. So if we talk about the chemical properties of hydrogen, hydrogen is not much reactive at ordinary temperature. However, at high temperatures, it is quite reactive. It forms a large number of compounds with almost all the elements except the noble gases under appropriate experimental conditions. Some important reactions shown by hydrogen are as follows. Okay, so what we will aware about it, that what you see here, that it is not you can say very reactive in ordinary temperature, but at high temperature it is very reactive. Okay, so first is combustion. Hydrogen is combustible gas and burns in air or oxygen with pop sound and nearly invisible pale blue flame to form water. Okay, so you can see here hydrogen react with oxygen and water in the form of gas is formed here. Okay, next is reaction with metals. Hydrogen combines directly with alkali metals, alkaline earth metals and certain rare earth metals to form corresponding compounds known as hydrates. Okay, we already read about these alkali metals, okay, in last chapters, so you will be get aware about it. So when it reacts with any metal, okay, it forms the hydrates. So you can see here sodium hydrates of metal, okay, by which hydrogen is react. Suppose hydrogen is reactive with calcium, so it will be formed calcium hydride. Okay, if it will be reactive with sodium, it will form the sodium hydride and so on. Next is reaction with non-metals. Under appropriate experimental condition, hydrogen combines directly with most of the non-metals except the noble gases. Okay, so reaction with nitrogen. Hydrogen reacts with nitrogen in the presence of catalyst iron or molybdenum, okay, at 475 degree centigrade and 200 atmosphere pressure to form ammonia. So you can see here three molecules of hydrogen react with one molecule of nitrogen, okay, in the presence of iron or molybdenum. One of them you can use, and at 475 degrees centigrade and 200 atmospheric pressure should be required, and ammonia gas will be formed. Reaction with halogens. Halogens, hydrogen reacts with halogens under different conditions to form hydrogen halides as shown below. Okay, if you see hydrogen halides here, hydrogen plus fluorine, if react they form hydrogen fluoride. Okay, so it is a halide of fluorine, and for chlorine you can see similar reaction occur, hydrogen chloride is formed here, and for bromine hydrogen bromide is formed, for iodine hydrogen iodide is formed here. So now we will talk about the reaction with the non-metals of group 6A. Hydrogen reacts with oxygen, sulfur, selenium and tellurium, elements of group 6A, to form their corresponding compounds under suitable sets of conditions. Okay, so you can see when water, if you see here, react with this oxygen first, it forms the water here, and when it reacts with the sulfur, it forms the hydrogen sulfide. Okay, next is reaction with carbon. Hydrogen combines with carbon at 1150 degrees centigrade to form methane in a small amount. Methane is formed, but it is very small amount. So it combined with carbon, then it forms the methane here. Next is reaction with metal oxides, or you can say it's a reducing property. When hydrogen is passed over heated metal oxides, it reduces them into corresponding metals. Thus, it acts as a strong reducing agent. So I hope you already heard the term strong reducing agent. So we are talking about the reducing property of hydrogen. Okay, as it is reduces, okay, metal oxides to their corresponding metal, so it is act as a very strong reducing agent. Some other examples here, okay, showing the reduction action of hydrogen are as follows. If you see, it reduces copper oxide to copper, okay, and lead oxide to lead. So this is the reducing property of hydrogen. As you know already, we will talk after that, I think, oxidation and reduction in detail. So I told you already that when removal of oxygen is occur, reduction is take place. So you can see removal of oxygen is taking place here from copper oxide, and it reduces to copper. Next is reaction with unsaturated hydrocarbons. Okay, in the presence of finely divided nickel or platinum, hydrogen react with unsaturated hydrocarbons, hydrocarbons containing double or triple bond. Okay, if you see presence of finely divided nickel, okay, hydrogen reacts with unsaturated hydrocarbons, okay, which contain the double or triple bonds such as ethylene, acetylene, etc. at 200 degrees centigrade to form saturated hydrocarbons. Okay, so it reacts with unsaturated hydrocarbons and forms the saturated hydrocarbons. So you can see ethylene, CS2 double bond CS2 is its formula here, and hydrogen react with it, okay, in the presence of nickel or platinum, okay, and it just forms the saturated ethane, okay. Same mechanism, same reaction occur for the acetylene also, and ethane is formed here. This reaction is used in the hydrogenation or hardening of vegetable oil. Sorry. Okay. So this reaction is used in the hydrogenation of or hardening of vegetable oil. The vegetable oils such as groundnut oil, cottonseed oil, etc. are unsaturated in nature due to presence of one or more double bonds in their molecules. When hydrogen gas is passed in vegetable oils at 200 degrees centigrade in the presence of finely divided nickel, their molecules get saturated and they change into solid fats, commonly known as vanaspati ghee. Okay, so vanaspati ghee, dalda is formed by this process. Okay, vegetable oil plus hydrogen, it will form the solid fat. Okay, it is known as vanaspati ghee. So these are the some reactions which we read today. Okay, in next class we will read about further things.